Once we know two triangles are similar, we can work out other things about the triangles. Let's have a look at a couple of examples. Here are two triangles. Obviously they are similar because they have three pairs of corresponding angles equal, 90, 90, 40, 14, 76, 76. They are similar. Why? Because they are equiangular. Now therefore it follows that corresponding sides are in the same proportion. So what we can write down is NL divided by CA. Why do we write those down? Because they are corresponding sides. So they, NL divided by CA, must be in the same proportion as NM divided by CB, because they are corresponding sides. And when we write down what we have, NL is X, CA is 2, MN is 24, and CB or BC is 8. So we have a little equation to solve. Multiply both sides by 2, and there we have it. 24 divided by 8 is 3, 3 2's are 6. The answer is X equals 6 centimetres. The length of this side is 6. We could do that in another way. Once we realise that these are similar because they're equiangular, we could look at the enlargement factor. Now the enlargement factor is obviously 3, because this side divided by its corresponding side is 24 divided by 8, which is 3. And therefore NL is 3 times its corresponding side, CA. That's what this little equation says here. Well, we know CA is 2, so NL must be 3 times 2, which is 6 centimetres. Same answer as we had before. Another example. Now, we've got to find an unknown angle. So we can't show that these are similar using equiangles. We have to look at the corresponding sides being in the same ratio. And if you look at it, 12 divided by 4 is 3. 9 divided by 3 is 3. 15 divided by 5 is 3. Therefore, we can say this time these are similar. Why? Because the sides are in the same proportion. Once we know they're similar, we know that corresponding angles must be equal. So alpha in this case must be equal to 37 degrees because it corresponds to this angle here. And lastly, a harder example. We have a small triangle and a bigger triangle. Now these are similar. Why? Because angle ABC in the little triangle is equal to angle ADE in the big triangle. Why? Because this angle equals this angle because they're in corresponding positions because of the parallel lines. Likewise, angle ACB equals angle AED. Why? This angle equals this angle because they are in corresponding positions because of the parallel sides. And lastly, angle A is common to the little triangle and it's also common to the big triangle. So the little triangle and the big triangle are similar because they are equiangular and therefore corresponding sides are in the same ratio. So let's look at some corresponding sides. AB over its corresponding side AD is equal to BC over its corresponding side, which is DE. I could also say AC over AE, but we're not interested in that because we don't have any information about them. So let's write in what we do have. AB is X. AD is X plus 6. BC is 2. And DE is 5. So again we have an algebraic equation to solve. Multiply both sides by 5. Multiply both sides by X plus 6. And we end up with this revised equation. Span this bracket and we have 5x equals 2 times x is 2x. 2 times positive 6 is positive 12, so it's 2x plus 12. Subtract 2x from both sides and we have 3x is 12. Divide both sides by 3 and we have x equals 4. The length of this side here, A to B, is 4 units. So there we have it, how we can use similar triangles in a variety of situations.